Alright, we've got a 7 1/4 inch saw blade, and it spins at 4,200 revolutions per minute. Part A would like us to find the angular speed in radians per minute. Okay, so one thing that they don't tell you in this question that you may not know, saw blades, when they give you the measurement there, that's actually its diameter. So the radius of the saw blade would be 3.625 inches. So no, I know not everybody knows that, so I feel like they should add that to the question. But so part A, angular speed is how fast it's turning at an angle. Well, they gave us that information in the question. It's turning this fast, this many rotations per minute. So that is how fast it's turning in a circle or at an angle. So the only reason this isn't your answer for part A is that it wants it in radians per minute, and it's currently in revolutions per minute. So part A is really just a unit conversion problem. We want to change those minutes. Well, we don't want to change the minutes. It's in minutes, we want it in minutes, but we want to change revolutions to radians. So if you want the revolution units to go away, you can't just ignore those. You need them to divide out. So a revolution in the numerator would cancel out a revolution in the denominator, and I can't multiply by anything other than 1, otherwise I would be changing the size. So I have to say that 1 revolution is equivalent to 2 pi radians. These are the same thing, so multiplying by 1 doesn't change the size. Well, that's perfect, because now I've got only radian units in my numerator, only minute units in my denominator, so it is ready to go. So that would be 8,400 pi, 1 times 1 is 1, and that would be radians per minute. Now the question doesn't say to round it, so personally I wouldn't. This is a better answer, but of course if I wanted to round it, I could go ahead and multiply the 8,400 times pi, and my calculator could tell me that is about 378 to the nearest thousands. All right, part B. Find the linear speed in feet per minute. So linear speed, and we can quit when we get it in feet per minute of the saw teeth as they contact the wood being cut. Okay, so the formula that we need to connect angular speed to linear speed is angular speed times r. So notice I didn't need to know r at all for part A, but I'm going to need it in here for part B. Alright, well, I've got two things I could substitute in for angular speed here. Angular speed is 4,200 revolutions per minute, but it's also 8,400 pi radians per minute. I don't know, if I put in some thought, one of those is probably better to use than the other, but I'm just going to take a guess. I mean, worst case is you pick one that takes a little bit more work. But so I'm going to take the answer I got from part A, multiply it by radius, 3.625 inches, and now I'm on my way. So I've got linear speed equals this big mess, but I've got to do some work to this big mess before I get it down to feet per minute. So let's see, we've got, currently we are in radian inches per minute, which doesn't make sense, but radians are a blank unit, so I can ignore those if I want to. So I really have inches per minute, and I want feet per minute. So I'm going to leave this guy alone, but I want to change inches into feet. So like part A, I have to make sure I multiply by 1 to not change the size, and to get these inches to cancel away, I need to put an inch unit in the denominator. So 12 inches is the same thing as 1 foot. Now when I compare my units, I've only got feet in the numerator, which I want, and I only have minutes in the denominator, which I want. So 8,400 times 3.625 divided by 12 and multiplied by pi. I'll let my calculator reduce that fraction for me. So here's the pi. I just didn't multiply it in, but I did 8,400 times 3.625 divided by 12. Changed it to a fraction and said I didn't multiply in pi, so it's still in there. So this would be my exact answer, and that's what I would always want to do given the choice, because it's a better answer. And the directions don't say here, so I personally would stop. If you just insist on getting a decimal answer, you could multiply 5,075 times pi divided by 2, and my calculator says that is approximately this many feet per minute.